Hi everyone. In this lecture, we will discuss on unsupervised learning, and specifically we will look into it hierarchical clustering techniques or algorithms. Here we go. The learning objective in this topic, first we're going to understand and the fundamental of hierarchical clustering techniques or the algorithm. And then we will discuss on the key algorithm and techniques, how we can carry out. Next, we're going to see that how we're going to adopt or implement this hierarchy clustering in the data set. Then we will evaluate and optimize the clustering result. And then we're going to apply the hierarchical clustering. It's one of the examples. And finally, we're going to discuss on the performance of this hierarchical clustering in terms of strength and as well as its weaknesses. All right, hierarchical clustering. First, hierarchical clustering is basically we can see this is one of the techniques listed under unsupervised learning method for clustering data point. Okay, clustering, the other words also we call as the grouping. So we're grouping the set of data which is we can find in the data set. So we'll see that how many groups can be exist. Okay, based on like once we plot all the points in that graph. The algorithm builds basically the clusters or groups by measuring that the dissimilarities between the data. Okay, so this is the way we develop that algorithm. And the mixed method also can be used on any data set in order to visualize and interpret the relationship between that individual data points. Okay, basically, when we just plot the data set into coordinate forms like in the graph, so we'll be able to see that the relationship or correlations between the data sets between X and Y, and we see how strong and how weak or there is no relationship between this data set or data points. And also we will use the hierarchical clustering in order to group the data point and visualize the clusters using both dendrogram and scatter plot. So this is all that we can do, we will see in the hierarchical clustering. Okay, let's see how it is works. So first, we will use that agglomerative clustering. Okay, agglomerative clustering is a type of hierarchical cluster that follow up that bottom-up approach. So I'll show you in a while how does it look like that the agglomerative clustering, graph or dendrograms. And we begin that treating each data point as its own clusters. Then we'll join the clusters together. Then we have the shortest distance between them to create a larger clusters. So first, what I'm going to do, we find, once we just draw that the cluster points, okay, the clusters which is belong to, and then we look into that, we join all the clusters into it. And then we look into the shortest distance between them, okay, within the clusters, in order to create the larger clusters. And these steps will be repeated, until one largest clusters is formed. Okay, so we can find that after we're combining everything, then we can have a look into the largest clusters within the data set. Okay, which means all the data will be centered in that particular area. Hierarchical clusters also require us to decide on both distance and as well as linkage method. Okay, so we can need to conduct a further analysis, like distance means like we use that Manhattan Euclidean distance and so on, or cosine distance, but we focus on Euclidean distance in this sense. And then linkage method, we use the Watt linkage method in these studies. All right. So as I mentioned, so we're going to use that the Euclidean distance Okay, and as well as we use that what linkage method, which attempt that minimize that the variance between the clusters. Okay, take a look at this example. A teacher wants to investigate the relationship between the number of hours students spend studying for an exam. So X values, okay, the number of hours spent and their corresponding exam scores. Okay, these are results which is the student obtained. We denote as Y. And the data set include the observation from 10 students. So as listed as below. Okay. So X values is the stand for the study hours. All right. So they given a different study hours as listed based on the 10 observation or 10 students. And then, for example, the 4, 5, 10 missed 4 hours, 5 hours, 10 hours, and so on. For Y value, this is basically the scores or the marks they obtain, okay, as listed here. All right. So 21 marks, 19 marks, 24 marks, and so on. This represent as well that marks, which is out of 25 achieved by the students. All right. So we have the two data set. One is study hours as well as marks obtained or the scores, exam scores based on these 10 students. All right. First steps, what all you need to do is we need to start that visualize some data points. So this is essential. You need to focus on this first. So in order to do that, we just write the coding in a Python environment or Python or Jupyter notebook. Okay, and the Jupyter notebook. So we just import the NumPy as NP, and then we just write import that matplot library and Python plot as PLT, and then we just list down all the X and Y value. So X, as I said earlier, it is the study hours, and Y is then for that marks obtained, okay, or exam marks. Okay. So in order to visualize the scatter plot, all right, based on these two entries, so what all you do, you need to come up with all these informations, okay, as plt.scatter x comma y in brackets. And then you need to plot what the x label is, and you need to plot what is the y value is. So I just give you an example so you can follow exactly the questions. What does it mean x? What does it mean y? So I just give you some exposures we need to write, okay? And then we're going to give a title, okay? So you need to explain what does it means, you know, what x versus y, which is like study hours over that mark obtained. And then we're going to plot the grid. Yes, of course, true. We're going to see that. And then we plot show. So we will see that the scatter plot as this. Okay. All right. So when you draw, this is the example. So when you just draw, it will show you that what the y component and what is the x component. And they will show you the title. All right. But your graph will be pretty much look like this. Okay. So they show you all the entries, the scatter plot. All right. Based on the given data set in the x and in y. Okay. So you'll get the scatter plot as this. Okay, now we're going to compute the watt linkage using Euclidean distance. And then we're going to visualize it using dendrograms. Okay, so that's what I'm going to do now. So in order to do that, you need to write the programmings, all right, for the under Python Jupyter environment. So import NumPy as NP, import matplotlib.python plot as PLT. All right, it's doing the same. Now, additionally, you need to add on from scipy.cluster.hierarchy import dendrogram, comma, linkage. Okay, so as we know, we got a data, all right, and then we're going to combine X and Y into a list of tuples. So just we're going to do data equal to list in bracket zip in bracket X comma Y. So you need to do that. Okay, so once you write that, the next you're going to write that the programming for that what method, what linkage method, and as well as Euclidean matrix or Euclidean distance. So we're going to perform the hierarchical clustering. So linkage data equal to linkage in bracket data comma method is equal to what method. So of course we're going to use that what linkage method. So we just write that WARD comma, and then metric. What we're going to metric. So we have a many metric. Like for example, I said We have Euclidean, Manhattan, cosine, and so on. So we use that Euclidean method. So we just write the Euclidean, right? Next, we're going to develop dendrograms. So we just write the dendrograms in bracket linkage underscore data. And then we're going to display the data in the form of graph. So we plot we just say plt dot shows. So we can see that the dendrograms. Okay. So you can see that the nice dendrogram, you can appear in the different colors, right? Is it green and red? Okay. They show you that the different clusters. Okay. And from here, we're going to interpret the data. Okay, I'll show you in a while how you're going to interpret this set. Okay, they show that each groups. Okay, so from the main. Okay, now next we're going to do that same things with the Python scikit-learn library, and then we visualize on two-dimensional plot. Okay, so in order to do that, you need to write again the import numpy as well as import that matplot library. And then we're going to add this from sklearn, okay, or scikit-learn dot cluster import agglomerative clustering. So you're going to add that. So once we're going to ஹலோ மா ரெக்கார்ட் பண்ணிட்டு இருக்கேன் இப்போ நீ போமா வீட்டுக்கு நான் வரேன் ஓகேம்மா பாய். Okay, we're gonna add that this from scikit-learn dot cluster import agglomerative clustering. Okay, and then we have the data set, the study hours, as well as exam scores. Then while we're going to combine x and y into the coordinate pair, so we just need to do this data equal to list in bracket z in bracket x comma y. So it's close bracket. Next, we're going to create an agglomerative clustering model. So as usual, you need to write that the code hierarchical underscore cluster equal to agglomerative clustering bracket n underscore cluster equal to 2 because we had to do of two clusters. So affinities is equal to, we're going to use the Euclidean, and then a leakage method we're going to use is what method. Okay, so this is what we're going to do. And then we're going to see whether the model is a fit and predict the cluster label. So in order to do that, we labels, all right, the models, which is labels equal to underscore, labels equal to hierarchical underscore cluster dot fit underscore predict data. Okay. Now, once you're done, the next steps, you're going to do plot that the scatter. All right. So as usual, just put at plt dot scatter x, y, and then we add on with that labels and plot x label with x values. X value, as we know, is a study hours, and the y value is a exam scores. And then the title, you can just put anything like agglomerative clustering. So basically the title you can also use as study hours versus exam scores. Okay. And then plot show. So you're able to see that the shapes as this, like two clusters. Okay. So now we're gonna see the summary. Okay. And every of what we have done, just now. So first is section, scatter plot, dendrogram, and agglomerative clustering. So purpose is the scatter plot in order to visualize the raw data, how does it look like. And then from here, we able to see that how many points, okay, the clusters is there, or is there any patterns, okay. And then under the dendrogram, the second part, Okay, so the purpose is in order to see that hierarchy clustering, and then from here we can able to understand that hierarchy and the number of natural clusters. Okay, just now we did, and then the agglomerative clustering. So from here we can see assign. The purpose is assign cluster label and visualize class result. Then based on that the agglomerative clustering, we are able to identify group membership, and then we confirm cluster separation. So we have a two separation, class separation. Okay, one is purple and this is yellow. Okay, so we have a two separation class. Clearly, we can see that based on that what method or linkage what. Okay, now we move to the interpretation. Okay, so based on the dendrogram analysis, we obviously can see that it show how classes are merged hierarchically based on the Euclidean distance and what linkage. Okay, and it's also we can see which is minimize the variance within the clusters. Next, y-axis represent the distance between that merging clusters. Okay, and then the higher value indicate less similarity. Okay, so you show that if the higher value is, which means is that less similarity. And then the key observation based on the cluster one, the points with low study hours, which is 3 hour, 3, 4, 4, 5, 6, and lower score is 16 to 22 based on that the dendrogram. And then for the cluster two, point with high study scores, okay, for example, 10, 10, 11, 12, 14. So we have high scores between 21 to 25. Okay, and the largest distance, okay, you can see to the vertical line is occur when merging these two main clusters, which is confirming the distance distinct group. Okay, so there is a the two different group that what I mentioned. Okay, all right. So this is the output. We are able to see that based on the result we obtained in the dendrogram. Next, cluster characteristic. As you can see that the cluster, we have two clusters as mentioned. So first cluster, the study hours, this one is 3 to 6 hours. So exam score is 16 to 22, 60 to 22 scores. I mean the marks. And then we can interpret low study time had a moderate score. Okay. For the based on the cluster two, so which is the study hours between 10 to 14 hours, and then the exam score is between 21 to 25, and the interpretation we can say that the high study time is a high scores. Okay, obviously we can see based on that the clusters analysis. Okay, now insights when we just looking into the dendrogram as well as the clusters, all right, the scatter plot. Okay, so what we learn from this, the positive correlation. Okay, the positive correlation, longer study hours generally lead to higher exam scores. Okay, this is the first conclusion we can make. Second, we can see that outliers. Okay, the student with 3 hours of study and score of 16 is outlier in the cluster one. So we obviously can see. Okay, so or we can even we interpret maybe the student is more intelligence. All right, he had know that the you know he knows the knowledge in advance. So this may he got us able to score, and then the student with the 12 hours and his scores to 21, okay, which is lower than the peers in cluster 2, okay. This may have that other influencing factors, like for example, maybe he may have their own personal issues, all right. That's a causes, all right. You get a such, marks, okay. The optimal study times. So the score is plateau around 10 to 14 hours is suggesting diminishing returns. Okay, is suggesting the diminishing returns. So these are optimals between 10 to 14 hours. Okay, now take a look on this the hierarchy cluster algorithm strength and weaknesses. If you can see that hierarchy clusters is a popular unsupervised learning method, but it had trade-off compared to other cluster techniques. For example, k-means and db scans. Okay, now we can see that the specifically, the strength and weaknesses, we can say that there is no need of that predefined clusters. Of course, it's unlike in the k-means, we don't have any predefined clusters, okay, in that hierarchy cluster. And then we have that hierarchical structures. That's the best part of it, the strength, which is the hierarchical algorithm has. And then it works with that any distance metrics like Euclidean, Manhattan, cosine, distance, any is work good. And then easy to interpret. Okay, is good at interpretations. When we come to interpretation, hierarchical method is one of the best. Okay, and is applicable to small and medium data sets. Okay, so it's only able to do that the small and medium data set. All right. Okay, now take a look on the weaknesses. So it's computationally expensive, of course. Like when we just deal with this clustering, it's computationally very expensive. It has a sensitivity noise and outliers. Okay, it's also like the result goes inaccurate. If it is, there is outliers. And its difficulties handling large data sets. Okay, when we just go for a large data set, it will be very complex, and some group we may not be see visible easily using a dendrogram because it looks so overlapping one to another. So it could be like very complex, like tedious, and we really cannot see that actual image. And then it has a static clustering, which is mean there is no reassignment can be made. So once we done the the grouping, all right, it's gonna be reassigned again in order to make another group. So that's one of the weaknesses. And then the choice of linkages affect the result. Okay, so of course, so for this case, we use the what method, but if you use a different type of linkage, then it will be affect the result. Okay, so basically this is the strength and weaknesses of the hierarchical clusters. Okay, now when to use the hierarchical clusterings. Okay, first, when we have a small to medium data set, at least the number of data set is less than 10,000. Yes, of course you can use that hierarchical cluster techniques. And then if the data set need interpretable hierarchy, so for example, biological taxonomy, document clustering, yes, of course, is the best part. The technique you can use is hierarchical clustering. And then do not know the number of clusters before n. So when we do not know the number of clusters before n, so we don't know how many clusters, then it's best to have a hierarchy cluster in order to see that how many groups is there in the data set. Okay, when we need to avoid it. Okay, when the large data set, especially when we have the large data set, big data, okay, when the data set is more than 10,000. So better we use that the k-means or db scan. All right, so it's no longer suitable to use hierarchical clustering if you're less than 10,000. And then the data is noisy data. Okay, there's too many outliers, the noises, we just use that db scan, okay, rather than use the hierarchical cluster. Need real-time clustering. Okay, so if you need a real-time clustering, it's gonna be too slow. Okay, so these are the when we need to consider, and when we need to consider, and when we do not use this array clustering. Okay, that's all. I think we can end up these lectures. Thank you and have a good day.